Aloha. Welcome back. Let's go a little bit deeper into our calculus and talk about the chain rule. So the chain rule basically says if you have a function within a function, when you take the derivative of that, you're taking the derivative of the inside function and multiply that by the derivative of the outside function. Okay. Well, let's kind of make more sense of it. It's really a composite function. All right. So if we have the quantity of x squared plus 1 to the 100th power, okay, hopefully you can kind of see that this is the two kind of functions in one, but that's the inside. So we start there and we call that u. You can call that x, y, z. You can call that Jordan Jumpman symbol. It's just a symbol, but we use u. It's just a variable. All right. So u is got to be equal to the inside function. All right. Then we have an outside function. We're going to call that y. So if u is the inside, this is going to be u to the 100th power. Hopefully you see that there. The derivative of u is just going to be 2x. Okay. The derivative of y is going to be 100 u to the 99th power. Okay. Well, I hope you can see that now. What was u? U was x squared plus 1. So we just substitute that back in. You take both of these derivatives and multiply them together. All right. Just multiply them together. All right. So we have 2x there. Okay. 2x. So you got 200x times the quantity of x squared plus 1 to the 99th power. That is our derivative here. So what did we do? We took the derivative of the inside times the derivative of the outside function. So you always want to separate it kind of into two. All right, cool. So I'm just going to rewrite this here as this quantity, but raised to the to the 1/2 power, right? Because we talked about the square root is the 1/2 power. All right, so now it's kind of like the first one, pretty straightforward. So that means that we're going to have a u, all right, and our u is just going to be the inside function, 3x squared plus 5x minus 2. All right, our outside function is going to be this, which is u to the 1/2 power. All right, so our derivative of u is going to be 6x, right? That power is coming down, plus 5. Okay, the derivative of u is just going to be 1/2 square root u, right? And so remember, because that half comes down, 1/2 minus 1 is negative 1/2, so it goes down like this. And so then we're going to also substitute. So I have square root of this here. Okay, and all we're going to do is multiply them together. All right, and so you should kind of see how this looks. So I have, because when I multiply this, this is definitely going to be on the top or the numerator. All right, so this is my derivative. All right, so kind of look at that, because whenever you have the square root of something and it's a function inside, the derivative has this kind of look where the derivative of the inside is kind of going to be on the top, and 2 times the whatever the inside, the square root of the inside function. All right, cool. All right, so this looks a little bit harder, but it's pretty straightforward. So you can pause the video and see if you can figure that out. All right. right, I'm going to make my life easier and just rewrite it like this. Okay, cool. All right. So we're going to go with our u, which is going to be the inside function. All right. Y is going to be the inside function to the -1 power. All right. Derivative of u is here. The derivative of the outside function, this -1 is coming down, u to the -2 power, or we could say this is 1 over u squared with that negative there. All right, so this is -1 over uh, this here. All right, and we could have did the quotient rule. So we see this squared here, and you can see that with the quotient rule. So we're just going to multiply both of these together. And so I have, when I multiply that, this is going to be in my numerator. All right, and I have this in my denominator. Okay, cool. Not too hard. Very simple if you know what you're doing, if you just kind of put it together. All right, here we go. Uh, the inside function is going to be the 3x because it's e to the x. So e to the 3x power. Our outside function is going to be e to the u. Okay. Derivative of 3x is just 3. Derivative of the outside e to the u is just going to be e to the u power. So this is going to be e to the 3x. Multiply both of the derivatives together, and I'm just going to get 3 e to the 3x power. Okay, cool. And remember that when you have e to something, it's going to come and have that derivative times e to that original function. Okay, it's going to look like that. So you should kind of be able to look at the next one and see what that's going to be. All right, and you can see that u is going to be x squared. Y is going to be e to the u because it's e to the x squared. Derivative is 2x. Derivative of the outside is e to the u, which is going to be e to the 2x because we put u back in, multiply them, we have 2x e to the x squared power. Cool. All right, cool. Now let's go to something a little bit more difficult. All right, remember we always want to kind of convert this. So this is more of the challenge where you kind of doing the chain rule twice, but nothing too hard. So we're going to go e to the x over 7 power plus 5, and that's going to all be to the negative, to the 1/2 power. Remember we did this. I want you to remember the form that it looks like, okay? Cool, because that same form is going to keep coming up, all right? So let's go here. We got u is going to be the inside function here, and y is going to be u to the 1/2 power. All right, well, in this case here, this is a special function here, so we'll call this, so e to the here. All right, we will just say, okay, w is the inside function here, and we'll call, instead of y, we'll call z is going to be e to the w power. All right, so the derivative of w is just going to be 1 over 7 because that -1 over 7 times x. The derivative of x is just going to be 1. So we got that there. So the derivative of z is going to be e to the w power. All right. So very straightforward. We got -1 over 7 times e to that x over 7 power. So we got this here. So we'll say negative 1 over 7 e to this power. The derivative of 5 is just going to be 0. All right. And so the derivative of the outside function is going to just look like this. And if we go ahead and substitute in w, we have this here. So pretty straightforward. Multiply those together, and we start getting something that looks a little bit like this. So you got a lot going on, but you're really only multiplying the denominator. So this, all right. So we'll just leave it. I'm gonna just leave it in this form. I'm gonna leave that negative where it is. I got it here. 2 times 7 is 14. All right. So nothing that cannot be done. All right. So we'll stop there. I do think that is enough, or we can do one more, but I think that's enough. Let's do this. Maybe we'll do this last one here. All right. Cool. So pretty straightforward. We got u is going to be this inside function. Y is going to be u to the 19th power. All right. Cool. So I'm just going to really rewrite this as e to the 2 t to the negative to the 1/2 power right there. All right. So obviously the outside function is going to be pretty straightforward. And if we substitute in u, we got this here. That's going to be straightforward. Now this one is going to be a little bit difficult. So we're going to come down here and we'll say that if I want to find the derivative of 1 minus, that is a chain rule problem, especially this right here. So I'm going to say that that's the chain rule I need. Okay, so I'm going to say that w is going to be negative e to, sorry, the inside function is going to be w. So w is going to be 2t to the 1/2 power. All right, cool. Now we're going to call this z. Z is negative e to the w power. Okay, w, the derivative of this, the 1/2 comes down, right? 1/2 times 2, oh, I'm going to just write it out, times 2, and then that's your t. 1/2 minus is looking like this. All right, so obviously these cancel out, so you're just left with the square root of t over 1, because this negative 1/2. So it looks like that. All right, this now looks like that, same, which is really just negative e. So we multiply those together and you get a negative 2 all over this here. So as we come back here, we're going to say that the derivative of 1 is that, and so I'm going to have negative e to the 2 square root x, square root t over the square root of t. So we got to multiply these together. So that may look messy, but it's not really that bad. that's going to be times 19, and that's going to be to the 18th power. All right, cool, no problem. Capiche?